And there's another thing about the photoreceptors that's completely different for birds compared to mammals, is they have an organelle, a structure inside the photoreceptor cell that we don't have. And it's called an oil droplet, which is cleverly named because it's a drop of oil. And it actually sits right in front of the photoreceptors themselves. So light has to pass through these oil droplets before it gets to the photoreceptor. And that acts to help filter the light.
Well, good morning. This is Phil Stair with Wisnetics, Poultry Podcast. And we're meeting with Greg Fraley this morning from Purdue. And Greg, you've got a lot to tell us about yourself. You're working in an area that I'm not very familiar with, so if you would, go ahead and introduce yourself to the audience about where you are and how you got there.
Well, I'm at Purdue University, and I was hired in 2020 as the Terry and Sandra Tucker Endowed Chair of Poultry Science. And my path was kind of long to get here. I'm originally from Baltimore, Maryland. I grew up in the city, never saw a chicken in my life until I was about 15, and we moved out to the country. And I had a choice at that time of either working in McDonald's or starting to work on farms. So that was a pretty easy choice for me, and got to know and understand birds or farm animals in general, and decided I wanted to be a veterinarian. And as I started shadowing and working in veterinary hospitals, I had a very important self-realization that I could not work with people every day who do really bad things to their animals. So when I started college at the University of Maryland, College Park, I was an animal science major, and again, learning more about farm animals, and took my very first physiology course with Dr. Brenda Mills. And she was absolutely fantastic. And I just fell in love with the field of physiology and decided to take every single physiology course I could find at the University of Maryland, which the last one was a course in avian physiology with Dr. Wayne Kenzel, and just absolutely loved the class. And Dr. Kenzel offered me a position in his lab as an undergraduate. So I started doing undergraduate research, which then continued on to a master's. And so my master's was in avian physiology in the poultry science department at the time. And after that, I moved to the West Coast, went to Washington State University, and to continue work on neuroscience, essentially. So my PhD is in neuroscience, and I am by training what's called a behavioral neuroendocrinologist. And that's a fancy term for saying that I study how environmental changes, and this can be environment in terms of inside a barn or inside of management decisions, or the internal environment, the physiological environment of a bird. I study how those types of changes can impact brain pathways involved with behaviors. And over the years, I have focused mostly on pathways that involve with feeding and reproduction, generally associated with growth and development. But about 10 years ago, I realized as I got more involved with poultry that all the manipulations I did, everything I was doing to understand these brain pathways was ultimately also associated with welfare. So for about the last 10 years, my lab has had a stronger and stronger focus on trying to better understand the neurobiology underlying welfare. What is an effective state, and what is the brain telling us about how that bird is feeling right now?
Jones Hamilton has become the poultry industry's animal health authority by combining research-driven products with expert support. Focused on science, safety, and sustainability, we empower producers to maintain healthier house environments. JH started with PLT litter amendment for pH and ammonia control, expanded with PWT for water acidification, and now supports organic operations with Diamate. The proof of our success can be found in bird performance, all backed by our 30 years of research. Learn more at joneshamiltonag.com.
That sounds very interesting. I was reading your master's degree and your PhD was actually looking at also the sexual dimorphism, I guess, the difference between boys and girls.
Yes. There are lots of sex differences in behavior, of course, but in the brain areas that regulate those behaviors. And it's very interesting. We are finding pretty big sex differences associated with welfare or a bird's ability to cope with stressors.
So I think one thing we've talked about in our email exchanges was just some of the visual inputs and some of the light issues. And that's still a hot topic. It's a personal topic. I've been working a lot with other organizations on light standards for particularly, heavy birds, broilers. But you've worked across different commodities. I'd be interested to hear what you've found to be common and different between the different species.
So that's a great question. And to start with that, I think it's important that we understand some of the anatomy associated with vision, right? We've got to understand how birds perceive their environment. And so you and I and most other mammals, we have 3 different receptors in our eyes for seeing color, okay? And with those 3 and combined with a few other grayscale colors, we see all of the colors that we see in the world. And I like to highlight this in mentioning that, my wife and I, it seems like we're in this constant perpetual state of home remodeling. And the part of that I absolutely hate the most is when it comes time to painting, right? And you go to the hardware store and you look at those color palettes of just thousands of colors. It's mind-boggling. And birds now, they have at least 4 different color photoreceptors. So one extra than we do. They also have another type of photoreceptor called a double cone, which may have something to do with perception of movement in their view, and in their field. And they also have a much higher density of these than a lot of mammals. So the bottom line that I'm getting at is there is absolutely nothing in our human experience that can prepare us to say this is how a bird perceives its world. Okay, you can see, with all due respect to Mr. Attenborough and his nature specials, which are fantastic, but when he says, here's how we see this butterfly, and they put a little UV filter down and say this is how our bird sees it, that's nonsense. It is not that easy. It is not that simple. And there's absolutely no way we could ever understand how a bird visualizes its field, perceives its environment. And so what I've done to try to address this is, most importantly, I teamed up with a colleague in biological sciences here, Dr. Esteban Fernandez-Harisic, and it is his expertise. Wild bird physiologists have been doing this for years, decades. And so we're just getting caught up in poultry science. And so what he does is we remove the retina, we remove the eyes of bird after they're humanely euthanized. We remove their eyes and we measure all types of characteristics, the size, the shape of the eye. We measure how light passes through the various chambers of the eye before it gets to the retina. Then we remove the retinas and we stain for we look at all of these different types of photoreceptors, their distribution. And there's another thing about the photoreceptors that's completely different for birds compared to mammals, is they have an organelle, a structure inside the photoreceptor cell that we don't have. And it's called an oil droplet, which is cleverly named because it's a drop of oil. And it actually sits right in front of the photoreceptors themselves. So light has to pass through these oil droplets before it gets to the photoreceptor. And that acts to help filter the light. So again, it's mind-boggling how different their vision is compared to ours. So we measure all of the oil droplets. There are different types of oil droplets. We measure all of them and which types of oil droplets are associated with different types of photoreceptors. And then we go into the barn environment and we measure everything about the environmental light. So we measure the spectrum of a light, always at the bird's head level, right? Because light changes with distance. We measure then the reflectivity of how light interacts with every single object in their environment. So nest boxes, feeders, nipple lines, waterers, whatever enrichment they may have. We even measure how light interacts with different parts of the duck. So their wings, their head, their feet, their bills. And we measure the wall, absolutely everything in the environment. And then we take all of these data, all the eye data, the retinal data, environmental data, and we plug it into these absolutely horrendously horrible mathematical models. And we get out information that's called a just noticeable difference, okay? And so it's a line where when we plug in all this information, what we can say is if you have this object with this background, under a specific background, under a specific type of lighting, can the birds see it or not? Okay. And so we have found some really amazing things. And so first off, with the Peking ducks that we've been doing a lot of this work on, we have learned that most birds have 3 different types of these oil droplets. The Peking ducks only have 2. And we've also found that, most birds, all birds have photoreceptors that allow them to see in the ultraviolet range. Peking ducks don't, or they have very few of them. So we believe that the Peking ducks have a reduced ability to see the ultraviolet, violet colors. Now, the question is, why is that? Is it because of domestication, or is it because of what we feed them? Because these oil droplets, they are formed from dietary oils. And so if we change the dietary oils, can we change these oil droplets? Are there age-related differences? Certainly you and I know that there are age-related differences in vision. There's absolutely no reason to assume that that's not the case in birds too. So these are questions that or another possibility is simply the lighting environment that we house them in. Does that change? Because the lighting environment in our poultry pretty much doesn't change. The type of lights don't change. They'll change the intensity of lighting, but whatever the light is in the barn is what the light is in the barn. And does that influence the development of the retina after hatch? So these are all questions that we're asking now.
So have you seen a difference going from incandescent to LEDs? Have you been through that transition?
No. And that's a great question. And that's a huge bit of misinformation. The only thing different about LEDs is that you can program the light spectra that you want. You can focus on that. You can get absolute monochromatic light, which means specifically just one wavelength. And they're a lot cheaper to use. In terms of the quality of light that comes out of them, in terms of how that light is interacting with the biological systems, really doesn't matter. Okay, so the technology is great because it's technology. But if we program an LED light to match the fluorescent lights of this room, it will have absolutely zero difference in their biological effects. If same intensity, all things being equal. So that's important.
Myself walking through chicken houses that have gone from incandescent to LED, running the same light intensity, supposedly, it appears brighter to my mammalian human eyes. And you just got to wonder what the avians, you do all the anatomy and relate it to physiology. That's the other question I guess I have in terms of changes. This sounds rather detailed and vigorous to extract eyes and look at, anatomical changes. To look at environmental change. Is there a mid-step somewhere? Is there a behavioral step or something else you can look at? We won't have to sacrifice the bird to make a determination whether the light's better or worse for them?
Oh, absolutely. Absolutely. And the behavior is always the next step. So what we have done in terms of all of the anatomy and physiology, this is absolutely necessary for us to model what they can and can't see under certain conditions. The absolute next step is we now need to do behavioral studies. And that's one of the things I'm doing. So with the blue lights or blue colors that we think the ducks aren't quite as capable of seeing under or not seeing that color, we are running preference tests. So we set up a big, long room with blue lights at one end, red lights at the other, and put the bird in the middle and see which way they go. I mean, just a very, very classic genetically designed preference tests. And we're just getting started on that. I've only done about 40 birds so far, and I want to do about 400 more. But it is becoming pretty clear that the birds avoid the blue light. They will walk towards the red light and stay there.
Is that an age-related effect, Greg, or is there
that's the next great question. I don't know. We're just getting started on this, so right now we're focusing on the adults because that's where all of our physiological modeling is focused at this time.
I guess it's a simplistic view, but what I've heard is blue lights for grow and red lights for reproduction.
Yeah. Yes.
Maybe too simple.
Yeah. I suspect it's too simple. And another key factor that we have to keep in mind too is we want to maximize the lights for the birds to help their behavior, keep them calm, maximize production. But we can never forget that there are people in those barns too. And I know there are some folks that push for the blue colored lights in layers. And I don't know if you've ever worked under blue lights, but it is horrible. We humans do not see. And I know the companies that have tried to put them in commercial houses, it lasts a month or two, and then the companies pull them out because the workers hate the environment so much. It's going to be a tricky key balance there. One of the things that's very, very cool with the LED technology is you can have the lights programmed so that the workers wear a little pendant. So when they walk into the barn, the lights change to what makes us happy, or makes best able to see and be safe. So that's I know one company that is exploring that possibility now.
Yeah, I've seen that too. Also in commercial production, people wearing headlamps. Particularly for a dim light situation that's too dim to get dark accommodated quickly, and you got to get your work done. You can't wait 20 minutes to dark accommodate.
Right.
And so they'll wear a headlamp where the dimmer light is better for the birds because they're there all the time. They've already accommodated.
Uh-huh.
I think a simple technology like that might be something too. Just get a headlamp.
Yeah. And I want to say too that along with Darren Karcher here at Purdue, we're doing the same types of modeling, visual modeling with layer chickens.
Okay.
And they have quite different vision than the ducks, which is not surprising. It's a completely different order of birds. Evolutionarily, anseriforms, the waterfowl, are much older. But they don't seem to lack the blue vision the way we think that Peking ducks do. But one of the things that's really cool that we've learned is under various common LED, even lighting systems in cage-free houses, when you have that stainless steel perch against a stainless steel background, like the cages, the layer, the system, we don't think the birds can see that perch, or at least not until they're really, really close to it. And so this could help explain why birds are breaking keel bones. Okay, so this is something that Darren's group is really investigating now. We've also found that under very typical, with the pine shaving flooring that they'll put down, the color of that against the color of the typical walls, outside walls of the cage-free housing, the birds can't see the difference between the floor and the wall. So they're not seeing a corner. So now we're wondering, hey, could this be something related to the piling that we're seeing in cage-free housing? So we're doing some really cool stuff, and we're, of course, with all science, we're getting more questions. It raises more questions than answers, but at least we have a pathway now to investigate this. We have a biological basis to start saying, okay, what if we change the color of this resource? What if we change the lighting inside the system versus the floor lighting in a cage-free house? Okay, what if we stop using blue-colored things in duck houses, right, to help them find their resources better?
Evonik Animal Nutrition is committed to ensure food security and safety while reducing the ecological footprint of animal farming. Its products and services use evidence-based solutions that seek to promote animal welfare and reduce reliance on natural resources. All this is underpinned by long-standing industry partnerships and deep customer understanding. Evonik's focus on efficiency, sustainable, healthy nutrition, and collaborations with livestock farming partners creates value for customers and consumers.
As this interim point, I guess, it sounds like there's a lot of work to be done. A lot of work has been done. But can you make recommendations now to be incorporated now, even with incomplete information?
So, yeah, I get asked that a lot. And right now, my recommendation is that all of these birds, just like us, despite thousands of years of domestication, they all evolved under the sun. So my recommendation is to stick with white light. And so what we have to figure out is what color of white light, right? So you can have the more romantic lighting down around 3,500 Kelvin or sunlight at 5,500 Kelvin. We need to figure that out. I suspect the cooler lighting is better, but that's kind of my opinion. Right now, I don't have hard data on that. I have some hard data in ducks, but I think, it's so we all get, scientists especially, we get suckered into new technology, and right, we want to play with these LEDs because you can get truly monochromatic light, and academically that's really cool. It's a lot of cool studies, but if you pick a light at 400 and a blue light at let's say 475 nanometers. But, birds, they're all different, right? Just like we are. You and I have certain genetic differences. So how you see is different than how I see. And if we have a bunch of birds in a barn that their blue light receptors are peak excitation at 450 nanometers, well, we're going to miss it. So one of my biggest recommendations is to always avoid monochromatic light in barns. You can use a single color like red, but red is a range of wavelengths. Avoid that monochromatic. And I just like white light.
And maybe a more common question is intensity and duration. That's the other. And the light program's more focused on not so much wavelength as they do and how much intensity and how long you do that. Do you have good science on that, or at least an opinion maybe to share?
I have some science on it. The problem is the common belief or the common observation in industry is if your birds are misbehaving, turn the lights down and they'll stop. And there is absolutely no refuting that usually, but it usually works. The question is why? I mean, are we turning it down to the point where they're just in the dark and so they can't see each other anymore, or they can't see their resources anymore? And so that limits the aggressive behaviors or poor behaviors. Or is there something else we could do to minimize that? So I think lights get turned down, I think unnecessarily. I think it's more of a coincident that this happens as much as being cause and effect. But again, it is a very common practice and it works most of the time. So there is something to it. I think a more important question is duration and the light cycle. And I am of the absolute firm belief that everybody needs a dark phase. Our birds too. I have, and it's common practice in various poultry industries to leave the lights on 24 hours because it improves growth and all of that. And that may be, and I understand that, but I think for their welfare, and I actually think for their health, having a dark phase is important. How long? Well, we need data for that. Because some of the things that I know, right, we all have, with our meat birds, we have all kinds of lameness issues because their muscles are outgrowing their bones. Well, one of the things we absolutely know in mammalian neuroscience, and it's suspected in birds as well, that after the lights turn off, that changes the brain chemistry and you get this increase in growth hormone. And growth hormone through various pathways will specifically act on bone. So one of the things I'm wanting to study, just haven't gotten around to it yet, is looking at the circadian rhythms of growth hormones and other growth-related hormones, inducing hormones, and to see what the circadian rhythm is, see what it is, and see if we can actually improve that bone growth by giving them a dark phase.
It's time for our famous three.
Are you looking for effective cleaning and disinfection solutions for your farm or hatchery? Look no further than Sidlines, an Ecolab company. Our AV Prime program offers advanced hygiene solutions that ensure thorough cleaning and disinfection of facilities and drinking water solutions. With products like Kenosan, Viracid, and our newest addition, Sid 15X, you can reduce pathogens, improve animal health, and boost productivity. Trust Sidlines, an Ecolab company, for cleaner, healthier, and more effective poultry production.
Maybe another question too, in conjunction with those two, is the interaction between the two. Light intensity and duration. Again, a commercial broiler experience in the southern United States lowers intensities. It seems the dark period is less meaningful, whereas maybe the more northern climates, I would say like Canada and even UK, where they tend to run brighter lights, the dark period seems to be more impactful. At least measurements when you look at efficiencies and so forth. Do you think there's an interaction there?
Absolutely. So the question there is, how much of a reduction in light does the bird perceive as changing from daytime to nighttime? And that's a question we don't know. We don't have the answer to that yet. And when I was talking before about a dark phase, I don't mean absolute dark, right? I mean, so unless you live in a cave, you're never going to experience absolute dark. No bird ever does, except for cave birds. So, having some light during that, we call it a SCOTA phase, the nighttime, I think is important. And definitely having the day and dusk, the gradual decrease at night and a gradual increase, I also believe is very important. I don't think there's anything magically physiological about that, but I think it just, I've been in barns when lights turn on and turn off, and it always spooks the birds. Every single day they get spooked when that happens. And actually it startles me too. So I personally understand it.
Greg, this has been great. This is Phil Stair with Wisnetics, the Poultry Podcast, and Greg Fraley. We've had a great conversation about light and response of different commodity groups, ducks and chickens to light.